Okay, so today we're going to talk about lesson 01, which is on representing functions. And so if you notice, what I've done is I've taken excerpts from your book. And so the very first paragraph here says, recall that a relation is a set of ordered pairs. So remember, a relation is any set of ordered pairs. The domain, okay, the domain of a relation is the set of all first coordinates, okay? Remember, the first coordinates are known as the x-coordinates. And the range is the set of all second coordinates, otherwise known as the y-coordinates. So the domain is the first coordinates, or the x's. The range is the second coordinates, or the y's. So a good thing to have in your notes would be domain is the first coordinates, or the x's, and the range is the second coordinates, or the y's. So that would be a good thing to write down. Not necessary to write down this whole paragraph. Just write that the domain is the x's, the range is the y's. So if we look at this first example, it says state the domain and the range of the relation. And so basically, all I've got to do is I've got to find what the domain is. And I've got some special notation that I'm going to use when I write this. Okay? I'm going to use D to represent domain, and I'm going to use R to represent range. I'm going to use set notation. So, D equals, and now what I need to do is find all of my first coordinates. So all of my first coordinates, I start with -3, 0, 1, 2. So that would be my domain, -3, 0, 1, 2. But if you remember, I said we were going to use some special notation. Here's what the notation is. I need to use set notation, which is right there. So after you write down all those numbers, you need to put those little squiggles, and those mean sets. Okay, so that's the domain. Fairly easy. I mean, it's not bad. All you have to do is pick the x's out. And this should look familiar because we did do this last year, or 2 years ago for some of you too. The range then, what will the range be? 3, -7, -5, 4. Now don't write in your book, by the way, when you circle those, okay? -7, -5. No, you're not supposed to write in those brand new books. And then we're going to use set notation. Okay? Now what you could do is you could put these in numerical order if you wanted, which would be -7, -5, 3, and 4. But it's not necessary. The other thing is if a number occurs twice, you don't write it twice. Questions on that before we move on to the next example?
So if there's 2 4s and you only write 1 4.
Right. So example, if I would have another ordered pair here and it would be 3, 4, notice you would have 2 4s in your range. You would only write it once.
What
Okay.
if there's a number in between?
And you would write it. All right, so here you go. A relation can be graphed on a coordinate plane. A coordinate plane is formed by the intersection of the horizontal axis, or the x-axis, which is the one that you already know, it's right here, and the vertical axis, or the y-axis, which is right here. The axes meet at the origin. Remember, we know the origin. The origin is the point 0, 0, which is right there in the middle. And divide the plane into 4 quadrants. Okay, remember the prefix quad means 4. Any ordered pair in the coordinate plane can be written in the form x, y. So here we have quadrant 1. Quadrant 2 is over here. We do use Roman numerals to write these. You don't just put the number 1, the number 2, the number 3, and the number 4. Quadrant 3 is located down here. And then quadrant 4 is located down here. Now you're probably wondering, what are those pluses and the minus plus? The plus here in quadrant 1 means the x-coordinate is positive, the y-coordinate is positive. In quadrant 2, the negative first means that the x is negative, the y is positive. In quadrant 3, what can you tell me about x and y? They're both what? Negative, good. And then in quadrant 4, what is positive? And what is negative? The y. Okay, so now we need to look at the following. It says name the quadrant in which the point Notice we always symbolize a point with a capital letter that's italicized. So this is point T. It's going to be located at the point negative 8, 5. So negative 8, 5, from my origin, where am I going to go? Left, how many? 8, and then what am I going to do? Up 5, so it's going to be located somewhere here, right? What quadrant is that? 2. So your answer would be 2. That's it. Think you can handle that? That should be review as well. Let's look at the next one. A relation can also be represented by a table or a mapping, and we did cover this 2 years ago. A mapping illustrates how each element of the domain is paired with an element of the range. So notice, I have ordered pairs, I have a table, I have a graph, or I have a mapping. So those are the 4 ways that we can represent a relation. Now, of those 4, probably the easiest one to determine what a function is, which is what we're going to talk about, is a graph. Okay? So remember, a function is a relation in which each element of the domain is paired with exactly one element of the range. Each element of the domain is paired with exactly one element of the range. Now this is the easy thing when we talk about a function. We're going to view it as a graph. And remember, a function always passes what? Do we remember what test this is called?
One spot.
Yep.
You go up.
So we call that, does anybody remember the vertical line test? Which basically means if I was to move a vertical line across my graph, it would only touch at one point. Okay? So if I take a vertical line, so let's just say I'm going to draw a vertical line right here. Okay? So far so good? I'm going to go ahead and make that red so that you can see it a little better. So let's go up to the graph up here. If I move that vertical line across the graph, does it only touch one point, at most one point at any given time? Yeah, it doesn't touch 2, right? So this graph here would be considered a function. Now, let's say, for example, I added a point in. Here, we'll change that. Let's say I added this point in. And now let's say I move that, just a second, there we go. Let's say I move that across. Is that going to be a function? Why not? Because right there, I touched 2 points. So that's why a graph is one of the easiest ones to determine. So if you get stuck and you're wondering if an ordered pair is a function, if the ordered pairs are functions, or if the table is a function, put them on a graph and then do the vertical line test. So let's go ahead and look at the next. State the domain and range of each relation, then determine whether each relation is a function. So let's start. This one, what's the domain going to be? 10, 6, 7, negative 8, good. Now what I need to do, oops, that was a bad squiggle. The range, what's the range going to be here? 3, yep, good. So now what I need to do is determine, is this a function? So remember, a function, each element of the domain is paired with exactly one element of the range. So I need to think if I graph these. So 10, 3, 6, 2, negative 2, 7, 4, negative 8, negative 9. Will there be any point at which it's going to be touching twice? No. Basically, this is the thing. You have to have some x's that are the same in order for it to not be a function. Okay, what I could do though is I could plot those. 10, 3 would be over here. 6, negative 2 would be down here. 7, 4 would be somewhere up here. And negative 8, negative 9 would be somewhere down here. So is that going to be a function? Yeah. So it will be a function, so we put yes. Okay, so let's look at the next one, domain. What's the domain going to be here? 1, 2, 3. Very good. Oh, whew. Let's undo that one. There we go. We'll write it again. Better. Okay, range. What's my range going to be here, folks? Okay. This is actually 3, 4, which basically means it's 2. So my range is actually going to be 3, 4, 7. Do I need to write the 4 twice? No, because I only need to write it once here. And so what this means, I could have written it this way as well and gotten rid of that 4 up here. And that would have meant the same thing. So now I need to think, is this a function? So if I were to do a quick graph, 1, 3 is going to be about right here. 2, 7 is going to be up here. 3, 4 somewhere around here. And then 1, 4. Oh. So is that going to be a function? Nope. Questions on that? Okay, we've got 2 more we need to look at. Domain. What do we got? I mean, this one, you should be able to answer the domain and the range. If you can't answer the domain and the range from that, then we've got some serious problems at the start of the year. Okay? What's the range going to be? We'll talk about those. Okay, so now I need to determine if this is a function. So if this is a function, okay, that means each element of the domain is paired with exactly one element of the range. So, is -3 paired with exactly one element in the range? Yeah. So this one works. Is 0 paired with exactly one element of the range? No, it's paired with how many? 2. So this one is no. If you liked to plot points, you could plot them as well. I've got the point -3, -4. I've got the point 0, -2. I've got the point 0, 0. So you see what those 2 arrows mean now? And then I've got the point 1, 2, and then I've got the point 5, 0. So those would be the 5 points. All right, let's look at the next one, domain. Ooh, this one should be interesting. Domain is the set of x's. So what are my x coordinates here? So what's my x coordinate of the first point? -1. What's the x coordinate of the second point? 0. Okay? 4. Good. So all I did is I looked at each of these points. So I looked at this first point. What's the x here? What's the x here? What's the x here? What's the x here? Let's do the range. So what's the y coordinate of this first point right here? -1. Good. What's the y coordinate of the second one? -3. Next one? 0. And what's the y coordinate of the fourth point? 2. Very good. So now I need to determine, is that a function, yes or no? Yes, passes the vertical line test. Great. Questions? So we've talked about domain and range. Domain again is what? X's. What's the range? Y's. Good. So for Monday, there you go on page P5, number 1 through 12. That is going to be your assignment. Should be short, sweet. You might be able to even get it done in this period.